For the next session, I'm very pleased to welcome Ansgar Koene here from the University of Nottingham, who's going to educate us a bit more on the black arts of algorithms and how they work today. So thank you very much.
All right, thank you very much. I'm not so sure that it'll be black arts necessarily, but I hope to speak a bit about how algorithms play a role in the experience that people have when they are online, especially the algorithms that they encounter on various online platforms. Because I'll be focusing on the algorithms that are used within platforms, I wanted to sort of start with an apology to all of the people who are doing great work to make the internet work from the point of view of its infrastructure, since algorithms, of course, also play an important role in routing packets, making sure that the information actually flows in an efficient way. I will not be speaking about that part because, as we all know, when infrastructure works well, everybody takes it for granted. Algorithms. Online algorithms and their implications for information access. The way I'll be approaching this is to focus on the kinds of algorithms that people generally interact with when they go online, when they go onto an online platform. So what is the kind of experience? I'll start off with the user experience when they go online onto something like a social network, or it can be some other kind of online service. So if you join a social network and you're just there alone, you haven't made any connections yet, you're not very happy, then you start making connections with a couple of people, which it becomes more interesting, you get more satisfied with the service. As you gain more people, and the boxes are sort of other services that are connected through the social media platform, the enjoyment of the system increases further. However, once the network that you're connected to becomes too big, the enjoyment drops. There's too much stuff, you don't know how to find the things that are relevant to you, and really that's where a lot of the algorithms that people encounter online, where they come in. They play an important role for people's experience online to make the online experience something that is useful and enjoyable because they help through smart filtering to guide people towards the information that is relevant to them. However, as we all know, there are issues around how exactly this filtering is being done, how to make sure that you give people the kind of information that they need, that they want, without filtering away things that they should also be seeing, part of which was actually sort of implied within the panel just preceding now. So ultimately, really, information services online, good information service, to a large extent comes down to good filtering. The general experience on the internet is not one of a shortage of possible information. There's so much information that exists that is connected online. It's all about finding the right kind of information. Services are being provided for free in the sense that you don't have to pay for them in cash. So the way in which they compete with each other is all about better filtering, getting people access to the information in the fastest, most smoothest kind of way. So really it's about appropriate filtering. Generally, this kind of filtering is moved towards the narrative is on personalization, making the algorithms work for the individual. And there's, broadly speaking, three kind of categories around this. There's the content-based filtering, which is really about looking for, based on the content itself, which kind of content is similar to other content that you have accessed in the past, and doing filtering on the basis of that. There's collaborative filtering, which is to say results that similar users like this person were interested in. So this is matching you to other people and saying, well, if those other people were interested in this kind of information and you are similar to them, then probably you're interested in that kind of information. And then there's the community-based kind of filtering, which is to say not just compare you as a basis of sort of your features that we've extracted from your behaviors online, but also looking at what is the community that you tend to interact with. And this is something that really came in through the social media platforms, Facebook being one of the big drivers of this, their social graph. So looking at if you are friends with this and this kind of person, you tend to connect with this person a lot, then you have similar interests to that person. So whatever those people are interested in are things that we will promote when you're looking for content. Now, what kind of an impact can these kinds of social media or information manipulating algorithms have? And so this was an experiment that was done a while back where they were looking at the impact of ranking on search engines. In the context of elections in India, they did an experiment in a couple of states there where they manipulated when people put in a search term, how high up in the search results would results from one political party be relative to another political party. And they showed that for the undecided voters, people who indicate they didn't have a prior strong preference, that there was actually a significant impact of shifting which party they would be going for. And the graph indicates just sort of the tendency of people to click on something or the time that they will spend on a site as a function of how high it is listed on the search results. So on the x-axis is the ranking position, and on the y-axis is the average time spent. And you can see that the amount of time and the probability of clicking on drops very rapidly as something goes down the list. So how the algorithm decides to rank things can have a very significant impact on whether people will actually see the content. The content still exists online, but people on things that are on the third page of a Google search result will never really be clicked to, will be never gone to. Ultimately, really, what we're seeing with the use of algorithms online is it's a trade-off between convenience and the level of control that you have. So you could go and say, well, I want to have total control, so instead of using something like Google search engine where you just type in a search word and you don't know how it's doing the filtering, I'm going to actually write SQL code of the exact way in which I'm going to search for it, which, yes, you would have total control, but it's really inconvenient, and most people don't know how to write that kind of a search query, including myself. So what we tend to do instead is go for something that is easier to interact with, is just a search bar. Okay, so this is first level of providing convenience through algorithms, but as we're moving forward to other kinds of platforms, the level of sacrificing control for convenience goes further. So if we're moving to something like a mobile phone, the space that we have on the phone is smaller. So if we're going to put something like a search result, we're going to have less stuff on the front page, the first page that we're going to see. So the way in which the algorithm decides how to rank things is going to have a bigger impact. If you move to something like voice control, we wouldn't want to ask the voice device, I'm looking for something like this, and then for it to rattle off 10 different potential results before you decide which one, because you wouldn't remember what the first one was by the time it told you the last one. Instead, now the algorithm basically decides completely for you, this is the one result that is likely to be interesting to you, so that's the one that it will give you. So as we move to different kinds of media that are supposed to be more convenient to interact with, because with the voice device, you don't have to walk to your desktop or even pull out your phone in order to do the query, you are sacrificing control for the convenience. As we're going through this process of having more and more algorithms involved in helping people get access to the information that is relevant to them, we do see, however, that the level of understanding of how the systems work is not really keeping track with it. So this was actually a study from 2015. Facebook had been around for quite a while already, and people were using it. And yet, 60% of the people that were queried in the study in the US didn't really understand that their newsfeed is algorithmically curated. They thought, well, I'm not getting any information from this person, so this person's probably not saying anything. They thought they don't get responses from one of their friends on Facebook. Well, that must mean this person doesn't really like me, isn't really that interested in me, whereas in reality, that person might simply not have seen your post because the algorithm decided that based on their past interactions, it probably wasn't sufficiently important to that other person. So how do we get people to understand the fact that algorithms are involved in the process and what kind of role they play is an important thing that needs to be looked at, and which is one of the things that we are also working at the University of Nottingham at the project that we're doing. But then the question is, how do algorithms work? Okay, so at a high level, you can say PageRank way back when was sort of the thing that the Google search was based on. Now it's quite different. They described with a nice kind of image of it's all about how this web page is pointing to other web pages, and how many other pages point to you makes you more important. Okay, that's sort of nice, but over the years, the actual algorithm became something that had 300 plus variables in it, and even most people in Google wouldn't be able to tell you how it works, and now it's started to involve machine learning as well. So really asking how does it work, why does the search result come at the top, is become a difficult question to answer in detail. And similar thing for things like the newsfeed algorithm. It's something to do with your general affinity, which we calculated somehow, to do with which generated some kind of weights for why certain things would be interesting to you, and some kind of a time decay function in it. Lots of hand-wavy things in that description of it, so you still don't really know why this particular thing comes high up. And if you've posted something and nobody else seems to be replying to it, you don't know, is this because people didn't really engage with it, or is it because the algorithm naturally didn't rank this highly towards other people, or is it because maybe someone else is deliberately pushing it down because what I posted was not positive towards the platform, and maybe the platform is deliberately downgrading that information. We, as general just user of the platform, don't really know, and this is something that is of concern. Another item is the way in which algorithms, and now more and more it's being presented as AI, is being presented to people is also misleading. So a lot of things actually now you see platforms saying, well, we need to be seen as innovative. Innovative means we're using AI, so we're going to claim that we're doing a lot of automated things, whereas potentially much of it is more of a mechanical trick of people doing it. On the one hand, we know a lot of things on social media involve massive amounts of low-paid people, click workers, doing work in the background. Doing the hard work of trying to filter bad content, for instance, is to a large extent human work. And on the other hand, on the marketing side, this was just a thing that Burger King did. They wanted to say, we are an innovative burger company, so look at how even we are using AI. For instance, in our ad, we had an AI build a TV ad for us. But of course, we all know that AI isn't perfect with language, which is why it's got these kinds of little funny mistakes in it, tastes like bird. The thing is, some investigation into the actual making of this advertisement showed that, yeah, they used an AI for some of it, but the key ones, the funny ones, were actually written by humans because the AI's text didn't didn't come out nicely. So photomation is a new term that is being coined around this, not by myself. You can look it up more here around this, presenting something as being algorithmic, being AI-based when it isn't. So AI-based, often when people talk about AI, they mean machine learning. And there's a big, question, a big uncertainty for most people around what does machine learning mean. In effect, what ends up being experienced by most people, or the kind of intuition people get, is that it's something like this. You pull in a huge pile of data, then you do something with it, you mix it, and look at the outcome. If the outcome isn't good enough, you'll just throw in some more data and mix it a bit more until you get the kind of outcome that seems to work. And okay, and it's clearly not explainable. If you look at it from a different perspective, a more mathematical perspective, a lot of the machine learning systems that are currently being used could be referred to as basically being computationally intensive statistics, with the addition that some of the optimization criteria are really embedded in the data sets that you use to drive the system, and in that sense are implicit, which is one of the reasons why you get problems of being able that like biased discriminatory results can come out even though you didn't want to build it in if you didn't make enough effort to make sure that your data sets are properly balanced. So this is to summarize or to help in the discussion around AI algorithmic decision making, just to summarize some of the different levels or of automation within the process. So starting on this side, we have rule-based decision making, which in reality is still being used in a lot of the services that people actually interact with. So this is hand-coded if-then kinds of rules. You add in enough of those if-then kind of rules, like Google a couple of years ago, 300 plus kind of parameters in there, and it's still not very transparent. Then you have towards something a bit more automated is statistical reasoning. Basically, this is using regression analysis and those kinds of approaches, where you are already looking at extracting from the data where you're going to set the boundaries between when to choose this action or choose the other action. And then moving forward towards machine learning, you're starting to automate more of this kind of process of identifying which criteria to use, extracting them more from the data. And then what would be thought of as true artificial intelligence, where the system itself starts to dynamically identify what the issues are, what the problems are, et cetera, is not really being used at all. As we've already heard earlier today during the explainer on AI, this is not something that's actively been solved yet, but it is where the community is trying to move to. So as I mentioned, one of the issues that arises with this automated process is a lack of transparency of how are the decisions actually made. If we're using a data-driven approach, there is implicit information within the data that defines your decision criteria, which we might not be aware of, might not be easily able to explain to people why they got that result. However, as I also already alluded to, even if you have something hand-coded, which you could graphically represent as if-then, 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 as a tree, if you build the tree big enough, it's also not really transparent. So the question of transparency actually comes down to the level of complexity, how many dimensions of inputs are you using, how many decision points are there, because you could write a machine learning, like a neural network, doesn't really look that different from a decision tree if you zoom out somewhat. It's really a question of how many nodes you've got. You could follow a single decision point through the neural network as well, write down its this input with that kind of a weight times this input with that kind of a weight, which is nice. You can write the rule. But if you write it out and you've got 1,000 points in there, then it's still okay. But now what do I do with it? How do I really understand why I got this? So the question is, how can you extract the important bits of information that will make it useful? Even when a human makes decisions, we use lots of underlying information we built up through our experience to make that decision. But when we explain it to someone, we don't tell them our life history. We tell them what were the key bits of information that led to this decision. We might go with just explain to them which part it is. If this bit had been different, then I would have come to the different kind of result. So from an experience point of sight, when we are engaged with a lot of with users, for instance, with 13 to 17-year-olds, one of the age group that we've been engaging with a lot, really what they're concerned about isn't so much that an algorithm is involved, but rather the loss of agency, the loss of control over how the system is working. And this is really the kind of thing that we need to be focusing on, how to provide people with agency over their experience online. And to a large extent, that relates to questions about algorithmic discrimination, which is, again, something that comes in often through insufficient attention to particular details within the process. And I'm going to have to skip over the details of this one. But the key question really about when thinking about algorithmic bias is to think about what we're really focusing on is unintended, unjustified, and unacceptable kinds of results, which might come out because of insufficient understanding of the context where the system is being used, failure to rigorously identify the decision and optimization criteria, failure to have explicit justifications for those criteria, and failure to check that those justifications are acceptable within the context of where they're being used. And also, to a large extent, systems that simply aren't doing what they were intended to do. So this was a very, very quick rush through the issues that arise with algorithms and online platforms. We have more information on our website on this issue, the interaction with young people on this in this space, and the work that we're doing with the IEEE to develop standards around ethical use of algorithmic systems. And finally, I wanted to point out that we will be having a workshop with Together Unbiased and ISOC UK on the 30th of November at the Cloudflare offices. And the announcement of this is now online on the ISOC UK website. So please do have a look and join us there. Thank you.